In this lesson, we're going to continue learning about rasters and learn about georeferencing, which is to take rasters that don't have spatial information, as in it doesn't know what the spatial reference is and it says it can draw it but can't project it, and how to add that spatial information into the raster. And in the process, we need to reference it to known points on a map and then have it warp the current raster to meet those points that we're saying. So georeferencing is how we take aerial imagery that doesn't necessarily have built-in GPS information, and once it's been stitched together into a seamless image, we can then view it and analyze it in a GIS context. So let's take a look. So this is some aerial imagery taken by a drone at my office, and it's for a meadow in the Sierra Nevada mountains. And it was stitched together by a program called PhotoScan. And once it comes out of that program, PhotoScan, if we provide georeference information on the input, can provide a georeferenced output. But in this case, I had it not do that, and we'll have to add it in ourselves. So first, let's get rid of the black boundary, and I'll go to the Symbology tab and have it display the background value of 000, which is black, as nothing. So I could have it be a color, but instead it's no color. So I'll click OK, and it strips out that background and makes it look like an appropriate null value. So if I zoom in, this is pretty cool. This is pretty high resolution imagery. It's much higher resolution than you would normally see in something like Google Earth. And we can get down to a pretty high level of detail. But that doesn't help us if we don't know where it is. So let's add a base map and see where ArcGIS draws ungeoreferenced information. So let's put it as imagery. In the past, we would have used any other known already georeferenced information to georeference a raster. So really what we need to do is we need a known bit of information to say certain points in our raster are equivalent to certain other points. And in doing that, ArcGIS stores this information and then uses an algorithm to combine it all together and stretch the raster to meet all those locations. And in the past, we probably would have used some other scanned image, but these days we can use a base map. So the imagery base map's giving me some trouble, and I suspect that the reason for this is because I added it after the image that has no spatial reference. So the data frame has no spatial reference, no coordinate system, and it can't draw the imagery. So let's set it to the same coordinate system as the base map, which is the Web Mercator coordinate system. I'll search for that, and we'll set the spatial reference of the data frame to that. And now it's happy. And where are we? We're at a scale of 1 to 97,000 here, so not totally sure where we are. But if we zoom out, looks like we're in the middle of the ocean. And surprise, surprise, we're off the coast of Africa here. And the reason for that is that this is really close to the 0 point, where latitude and longitude are 0. So it's drawing it there because it doesn't know where else to draw it. And in georeferencing, we need to give a starting point by going to the spot that we know it is and then fitting it to that window. So let's do that now. And first, let's add the georeferencing toolbar. Once again, this is done with a toolbar. I'll add that in over here, and let's close catalog. And now let's go find the location where this meadow is. Okay, so it's down here, and it's in this area. And let's crop even tighter. And once we think we're kind of close, and I'm looking at the image on another screen as a reference right now too, so you'd want to do that. Once we think we're relatively close to where it would be, I'm going to use the georeferencing toolbar, and I'm going to select Fit to Display. And it looks like it's maybe a little low. This edge should be in this pocket over here, and you're going to use your expertise of the area that you know in the images to match it on the ground. So I'm going to move up a little, and I'm going to do Fit to Display again, because I want to get it pretty dang close when I do that first Fit to Display. But when we do that Fit to Display, it moves the ungeoreferenced image to your current view. It says, okay, we're going to give it temporary georeferencing and move it to your current view. And this is a great time right now to set it to semi-transparent so that we can see the base map through it. So I'll click apply there. And what I know is I need these curves in here to align. So I'm not quite there yet, but I'm pretty close. I'm going to turn this off and then back on, and we'll see how these align. This right edge seems good. It looks like I need to zoom in ever so slightly. I'm going to fit it to display one more time. And it looks like that wasn't quite as good, but let's move it over and keep adjusting this. And now I'm pretty close. I feel pretty good about this. Now is when we start the bulk of the actual georeferencing work. And the first thing I need to do is I need to turn off auto adjust. I don't want it to adjust the image in front of me until I get a couple control points in. Because if I do, it might flip the image upside down on me or something. And then I need to add control points. And control points are where I say a spot on the image is equal to a spot on the ground. So now let's zoom in. We're not auto adjusting anymore. Or we're not fitting to display anymore. And what I want to do is I want to find the features in my image that align with the features on the ground. So I could see the stream channel here. It's not the best way to align these, but it'll work for now. And I'm going to click on the feature in the new image that matches the feature in the old image first, and then I'll click on the feature in the old image. And so it's a from this location to this location. I'm saying this spot needs to be moved from here to here. And now let's zoom back out. Now I have one control point. And let's find one somewhere on the other end of this raster. And here's where we got the scale wrong. So you can see that this is a hard process for natural features to figure out what's what, especially in a changing landscape. But this bend in the river here corresponds to this faint bend that we're seeing through here. So I need to move, let's find the sharpest corner we can here. I'm going to take the top of this thing and I'll zoom in here and we'll attach it to the top of this bend here. And now is where this gets a lot easier because I'm going to turn on auto adjust and it's going to resize my image for me. With those first 2 points, it finally gets things to about where they should be. And there will still be things that are in the wrong spot, but I'm no longer having to find features all across the landscape and say, okay, these two things align. They're going to be relatively close in space to where they should be. Now, here's the ticket, which is that in most cases, you want to find locations that are around the edges because you're going to get better data, better accuracy if you can disperse your control points all around the image and especially around these edges, because with control points only at the bottom, when we warp this image ultimately, these top areas don't have any information. So I need to make sure that I get locations all around this image as much as possible so that it can have definite locations that the image needs to be warped to match anywhere around the image. And it looks like this is pretty close, but this little bend in the river here needs to be moved just slightly down. So I click on it and then I click on the new location and it snaps it there. And the image now with the auto adjust on aligns a little more accurately. And let's go see if we can find a tree over on this edge of the image. And I think that these are slightly misaligned. So I think this spot needs to move to here, but this spot needs to move to here. So with each adjustment, we get slightly better alignment on our image. I also think that this tree down here needs to move up here slightly. And slowly but surely, we're aligning our image to the landscape, doing our best to disperse these points as much as possible. Let's see if we can get something on this edge of the image. Already it looks like these stream channels are pretty tightly aligning with where they should. And same with this channel or canal over here. It's about as close as I can hope to get it. And this tree overlaying here. What we're going to have a much harder time with is this area out here where we see these remnant channels or these former stream channels. And it's hard to say if we're aligning with them. It looks like maybe we can get a control point in right in here. And I need to move this edge over here from here to here. And now For the sake of this demo, that's probably all I'm going to do. But we need to disperse our control points around the image as much as possible so that we can get an accurate alignment and an accurate way to tell ArcGIS where each spot in this image belongs. We can also get a link table where we can see all of the information here and our residuals and our total root mean square error. We want to get this root mean square error as low as possible because it's a measure of how poorly or how well we have aligned the image here. Basically, how much adjustment and error it needs to make for each one of these control points and how much they're kind of pulling away from each other. In a way, it's a lot more complicated than that. More control points usually make your root mean square error better as you refine your image, but removing a bad control point with high residuals is probably a good idea because it might indicate that you didn't actually find the feature you were thinking you would. When you think everything is good enough, what we need to do is export the image with the final warp. So I'm saying this image is good enough right now, and I need to rectify it. So I can save the current warp to this data set, but instead I'm going to rectify it. And I'm going to use the nearest neighbor resampling type. And I can set the output location to my default geodatabase, and I'll give it its current name, but I'll say it's now referenced and have no compression type and save. And what it's going to do is it's going to rewarp the whole image. It's going to rewrite all the pixels so that they best match the referencing information I've told it for these individual points. And then as a result, I'll get a georeferenced image back. This takes some time, so as you can see, it's 0% at the bottom. Okay, now we can add that data in. So I'll go find my default geodatabase here. Here we go. And it's this one. And when I add it in, it's already referenced for me. And in fact, I can remove my georeferencing raster now, and this one stays referenced. Okay, so that was maybe a harder example of the many that we could have used of how georeferencing works in ArcGIS. Using georeferencing, we can take raster imagery or other rasters that don't have spatial reference information and give them locations on the Earth and then warp them to match the locations we're saying that each individual point matches. Georeferencing is less and less important in many disciplines now, but it's more important with the rise of drone imagery. So it's a good skill to at least be aware of and then get some practice with at the point that you need to use it. So I hope that helps, and I'll see you next time.